Okay, let's finish 4.4. I've moved to number 6 on the next page. Log of 3x plus 2 plus log of x minus 1 equals 1. Okay, addition becomes multiplication inside the logarithm. Again, this is log base 10, so I need to raise 10 to the power on both sides. 10 and log on the left side cancel, so we have 3x plus 2 times x minus 1. 10 to the first power is 10. So it's important that you know what you're doing there. I need to square these out. This is 3x squared, well, not square them, multiply, plus 2x minus 3x minus 2 equals 10. So 3x squared minus x minus 2 equals 10. Subtract the 10 over. We get 3x squared minus x minus 12 equals 0. So here's where I have to factor. So in theory, I'm looking for factors of negative 36 that add to negative 1. The factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9, and then 6 and 6. However, if you notice, none of these actually add up to negative 1, which means this can't be factored. Now, I do have alternate methods for finding the solutions. One of them is the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a that we've used before. So sometimes I'm going to have to use this. So we've got 1 plus or minus the square root of negative 1 squared minus 4 times 3 times negative 12 all over 2 times 3. 4 times 3 is 12 times negative 12 is negative 144, but it's a minus a negative 144, which is actually plus 144. So this is 1 plus or minus the square root of 145 all over 6. Now, probably wondering, okay, so there's an issue here. I need to check my answers, but I don't 100% know where this is. So let's talk about what the square root of 145 is close to. It's really close to 12. So this has to be close to 1 plus 12 over 6, and then 1 minus 12 over 6, because the square root of 145 is only a tiny bit bigger. So we've got 13 over 6 and negative 11 over 6 as our possible options. So when I plug them back in, that's what I'm roughly going to estimate. So if I plug in 13 over 6, which is a little bit bigger than 2, I can roughly approximate with 2 if it's going to be positive or negative. 3 times 2, 6 plus 2 is 8, positive. 2 minus 1 is 1, positive. So the plus version should be fine. Negative 11 over 6, which is close to negative 2. 3 times negative 2 is negative 6, plus 2 is negative 4. Negative 2 minus 1 is negative 3. Both of those are negatives, which we can't have in the logarithm, so this is out, which means the minus version of this answer is out. So my only actual solution is the one with the plus. So 1 plus the square root of 145 all over 6 is my only solution. Okay, we continue on the next page. Solve the following involving logarithms. Okay, let's do number 2. ln of 4x plus 3 minus ln of x equals the ln of 5. Again, subtraction becomes division. To cancel out an ln, I'm going to take e raised to the power. So we get 4x plus 3 over x equals 5. Move the x over, 4x plus 3 equals 5x. And we get 3 equals x by subtracting the 4x. Now I can plug this back in to make sure. 4 times 3 is 12, plus 3 is 15, so positive. The ln of 3, positive, totally fine. Not a bad equation at all. Solve the following equations for the variable c. So we're not going to get an actual number here. We just need to practice getting the number by itself. So let's look at number 2. b minus 2 equals the ln of 4c plus 11. To get rid of the ln, I need to raise e to the both sides, so that I get e to the b minus 2 power equals 4c plus 11. To get c by itself now, it's just subtract 11, and divide by 4. So c is actually equal to e to the b minus 2 power minus 11 all over 4. Feels weird, but it works out just the same. Now the last thing we could have is some word problems. Most of them are pretty simple. For example, the number of tablets that are sold in the United States per year can be modeled by the function f of t equals 20.57 times the ln of t plus 10.58, where t is years since 2009. Estimate the tablet sales in the United States in 2015. Okay, so this is years since 2009. I know 2015 is 6 years. So I just plug in 6 for t. f of 6 equals 20.57 times the ln of 6 plus 10.58. This is definitely a problem that would require your calculator, or I would have to have you leave this answer. Okay, when I put it into the calculator, 20.57 times the ln of 6 plus 10.58, I get approximately 47.4, we'll go with 44. And this is in likely millions. So 47.44 million, which is a whole lot of tablets sold in the US. If the trend continues, in what year will tablets eclipse 60 million? So I set 60 equal on the left side, 20.57 ln of t plus 10.58, and now I'm going to go backwards. Subtract 10.58. We get 49.42 equals 20.57 times the ln of t. Divide by the 20.57. I'm going to approximate that here. 49.42 divided by 20.57 is about 2.403. And now to get t by itself, I need to take e to that power. So e approximately to the 2.403. This is about 11.05. Now what does the 11.05 stand for? It stands for 11.05 years since 2009. Now one rule of thumb, since we need to go above 60 million, and it'll take over 11 years, first full year, you have to round up, will be 12 years after 2009, which is the year 2021. Now lastly, the total expenditure of a company can be given by the equation f of x equals 25 times 1.09 to the x, where x is years since 1990, and the amount is in billions. Find the amount of money spent in 2011. That's 21 years since 1990, so it's 25 times 1.09 to the 21st power. And again, you'd have to approximate using your calculator, so 1.09 to the 21st, and then times 25 is 152.72 billion, which is a ton of money spent in a year. So 152.72. Now find the first year in which they spent over $100 billion. You don't need to guess and check this. You just put 100 over here. Equals 25 times 1.09 to the x. Divide by 25. 4 equals 1.09 to the x. So in the past, you would have had to check values. Here, we know how to get this. If we take the log of 4, equals the log of 1.09 to the x. Bring the x down. Log of 4 equals x times the log of 1.09. And then divide by the log of 1.09 to get the log of 4 over the log of 1.09. To get x is approximately 16.086. Now again, you have to round up, so x is 17 years after that 1990, so that's the year 2007, and that is all for 4.4.